So, you've got this brilliant, general-purpose AI that knows, well, almost everything. But how do you actually teach it a real-world job, a specific one? It's a massive challenge. And today, we're going to dig into a super interesting new idea from Anthropic that might just flip the script on how we build specialized AI agents.
I mean, think about it. These huge language models we have today, they're kind of like incredibly smart new graduates. They've got a ton of book smarts, this vast general knowledge, but they lack that specific on-the-job training. They have no idea about your company's brand guide, or the exact steps for filing your expense reports, or how to use your quirky internal tools. And this, right here, is where things get really clever. Instead of trying to build these super complex, one-off agents for every single task, Anthropic is asking, what if we just treated it like a new employee? What if you could just give it an onboarding guide? A simple, easy way to package up all that specific knowledge. Well, that's the big idea we're talking about today.
All right, so here's the plan. We're going to start with what these onboarding guides are all about. Then we'll take a look under the hood to see how they're built. After that, we'll uncover the secret sauce that makes them so efficient, compare them to the old way of doing things, and finally, we'll look at the absolutely wild future this could unlock.
So, the official name for this new approach is Claude Skills. This is Anthropic's big answer for turning a generalist AI into a specialist that knows exactly what you need it to do. And what's cool is, this isn't just for huge tech companies. It's a way for pretty much anyone to teach an AI their own unique workflows.
So what is a skill really? Well, at its heart, it's just a folder. Seriously, it's a folder packed with expertise. Instructions, bits of code, reference guides that Claude can find and use only when it needs it for the job you've given it.
And here's the part that's actually kind of revolutionary. This isn't some complicated new framework you have to learn. The real power here, and the reason I think this is a total game changer, is its radical simplicity. It's one of those things that feels almost too simple to be this powerful, and that's what could make it possible for anyone to build their own AI tools. Okay, so if it's just a folder, what's actually in it? Let's pop the hood and break down the anatomy of a skill to really see what makes it tick. It is honestly this simple. You've got your main folder. Inside that, there's one really important file called skl.md. It's just a standard text file with the main instructions, and then you can sprinkle in some optional extras like reference documents or Python scripts to make the skill even more powerful and reliable.
To make this less abstract, let's check out a real skill that Anthropic actually built. Its one and only job is to create animated GIFs that are perfectly sized and optimized for Slack.
Now, what's so cool about this is how it mixes simple instructions with a little bit of code. Claude gets the directions on how to make a GIF, but it also gets a tiny Python script. And this script acts like a little quality control agent. It basically checks if the final GIF is under Slack's 2 MB size limit. If it's too big, no problem, the model gets that feedback and just automatically tries again until it succeeds. That's how you get really reliable results.
Okay, this all sounds great, right? But wait a minute. If you have dozens of these skills, aren't you just going to clog up the AI's short-term memory, its context window, with tons of instructions? Well, the answer is no. And that's thanks to this really elegant design principle they're using called progressive disclosure. This is the secret sauce. So at level 1, think of it like a table of contents. At the very beginning, Claude just gets a tiny little summary of every skill it has access to, just a name and a quick description. This uses up barely any of its memory, but it gives the AI a complete menu of all its possible capabilities. Then, when you actually ask Claude to do something, it scans that menu. If it thinks, hey, the Slack GIF creator skill looks perfect for this, only then does it bother to read the main sk.md instruction file. It's like turning to the right chapter in a textbook instead of reading the whole thing from cover to cover every time. And check this out. It gets even smarter. For really complicated tasks, that main instruction file can link out to other documents, kind of like an appendix. Claude can choose to go read those extra files only if it gets stuck or needs more detail. This basically means a skill's potential knowledge is almost unlimited, but it never floods the AI's working memory.
So how does this new way of doing things really stack up against the old way? Let's put it head-to-head with a much more complex approach you might have heard of called the Model Context Protocol, or MCP.
And I mean, just look at this. The difference is night and day.
Token usage, that's the AI's memory, is super low for skills, but it can be ridiculously high for MCPs. And complexity, skills are just simple text files anybody can write. MCP is a whole complex system you have to learn. The one trade-off is that skills need a coding environment to run, but honestly, that's what gives them so much of their power.
And you don't have to take my word for it. This quote from Simon Willison's analysis just nails it. The biggest problem with the old way is that the instruction manual can be bigger than the actual workspace. If you use up all the AI's brainpower just telling it how to use a tool, there's not much room left for it to, actually solve your problem.
So it all comes back to this, doesn't it? The most crucial thing to understand is that skills are powerful because they're not some fancy, complicated system. They're a simple, intuitive format that just trusts the language model to do what it does best, figure things out. So, where is all of this headed? When you make a tool this simple to create and this easy to share, you basically open the floodgates for something incredible. The potential here is honestly kind of dizzying. Just picture this for a second. Let's say you're a data journalist. Instead of needing some giant pre-made software, you could build your own custom AI agent just by grabbing a few different skills and putting them in a folder, like Lego bricks for AI.
And this is just a beautiful illustration of how it works. You could have one skill that teaches the AI where to find census data, another one that shows it how to use the right data analysis tools. You could even have a skill that's just an expert's written guide on how to find interesting stories buried in the numbers. And just like that, you've built a super powerful custom agent with nothing more than a few text files.
And for so many of these powerful skills, the barrier to entry is just one single file. When it's that easy for people to create and share their expertise, you could see what some are calling a Cambrian explosion of new AI abilities, built not just by big labs, but by everyone.
And that's really the heart of it, isn't it? The magic here isn't some brand new, complex piece of tech. It's a shift in philosophy. It's about giving the AI well-structured knowledge in a simple format, and then just trusting its incredible intelligence to figure out how and when to use it.
So this leaves us with a really fascinating question to chew on. We're moving away from a world where AI capabilities are handed down from a few big companies to one where any expert can package up their unique knowledge and share it. So the real question is, what's the first thing you're going to teach it?